Yo. Oh. All right. Gonna wait for Insia here to join. Let's see if actually anyone's out there. Hey, hey. Looks like my camera's not hooked up. Looks like my camera's not hooked up. Okay, we're gonna clean this up. Valencia waits to join. Jump on our Slack if you wanna, interact with me directly. But Insia is gonna join here. Waits to join, and I'm hearing myself. So let me go find it if you wanna, interact with me directly. But Insia is gonna join here. And I'm hearing myself. So let me go find it. All these tests work. All right, let's just start cleaning up some of this stuff. Let's go find the test. All right, let's clean this code up. So Insia said she's going to join. I'm just going to start cleaning up these tests. All right. I don't need the palm. I don't need the readme. I don't need this. This is the coder object. This works fine for me. All right. That's just it for debugging. All right. Here's the test. Here's the data store object. So we got some commented out code. Let's delete that. And Incio should be joining any minute here. All right. All of this is in the test stuff. Cool. Probably should just slide this over back to where it needs to live. Refactor it all. Rerun our test. Probably need to fix import. All right. Keyboard. And Incio wants me to email her the Zoom link. Yeah, let's see if I can just send it to her. I can open up a just import everything. While we wait for Incio to join, why can't we find class coder? Been a minute. Let's stop all the that's what Incio joins. Incio. what I think we want to do is just we want to get rid of equal. We want to get rid of some of the stuff. We're just going to take it down to the bare minimums. We don't need that. We can use singletons and use Java. Do what Java does best. Oh. Hey, look, it's Insia. Hey, Insia. You're on mute, Insia. You're still on mute, Insia. Oh, good, good, good. I'm cleaning up some of this mess here. We're streaming this to YouTube just to get the algorithm to like us more. So tell Yusuf to behave himself. I know. He should probably take notes. I'm going to change my. All right. So, Insia, what I did was I was going through and looking at the code we did, and I'm just cleaning up stuff that we had too many cooks in the kitchen last time. So I'm just removing anything that we don't need. Is that okay with you? Well, let's just start with the basics here. And let me delete it anyways, because it's going to yell at me. And we'll just start from scratch. So, aren't you excited to code? My wife went to bed early. My baby's asleep. And I figured I haven't written code in a week. I should go write some code. So, what are you up to? Oh wait, don't mention where we're streaming us, so make sure you're. Not a big deal. No one's gonna see this. But yeah, plans changed. Yeah. All right. So I got. All right. Just to review, you wanna learn arrays, right? The actual computer science behind arrays, correct? Okay. So, all right. So the use case we're going to do is we're going to build a coder relationship management system or database, right? Because data structure, database, it's not pure luck we call them that. The idea is a data structure is a way to store data. And the first easiest way in object-oriented programming is an object, but I think you're familiar with that, aren't you? Yep. So we just have a coder object here. Is that big enough for you to see? I can make it bigger too. All right. So we have a coder, okay? And I'm going to use a test, but we're not going to do test-driven development. We're not going to be dogmatic about it. We'll write some tests to show how the code works, but we won't do proper TDD. Are you okay with that? Because TDD is a good technique, but to get through hard interviews on a whiteboard, you need to understand how the code works. So we'll focus more on that. So we're going to write a test to store two coders in the data store. Are you good with that? And what I'm going to do is I'm going to create two coders. I'm going to create a coder named coder1. Okay. And yep, we're going to store these in an array. Coder2, right? So we'll so back before you knew how to do arrays, this is how you would track two coders, isn't it? Coder1 and coder2, correct? And let's say we had coder3, it would be coder3 And that would be fine, but how many times would you statically type this out? Right? So arrays are great because they allow you to do, they allow you to store multiple objects of the same type in a bucket, but they don't allow you to grow the bucket. It's a fixed size, and I'll show you what that means. So stop me if you have any questions. It's been 20 years since I took this class, and I can try to remember. So what we're going to do is we're going to create a data, the coder relationship. We're going to create a data store. I'm just going to call it a data store. And we're going to call data store equals new data store. And I'm just going to fly through creating this. And we're going to do data store dot add coder 1 data store dot add coder 2. Follow me on this? Okay. And then we'll do something like assert that yeah, that sounds good to me. Assert that data store get all, right? Length, and I'm doing this by memory. We'll fix this with some test here. I think it equals 2, and I think it's the other way around. All right, so in CL, I'm going to just rapidly build this out. Create class data store. Yes, do this. Add, yes. Back in my day in CL, we used to have to write this code by hand. All right, data store. Create local variable. Oh, I don't want to do that. We just want to use, oh, I typed wrong. You're supposed to catch me on that. And then data store length, get all. Okay, returns an array. Create method, data store, get all array. So let's plumb this out, okay? All right, so an array, and we're using Spring Boot because I'm going to do some things. So when you declare an array, it will look something like this. And equals new coder. Okay, I think it looks like this. It's been a minute. It's been a week since I wrote code. Okay. Okay, and I'll walk you through this. So this is an array. Are you familiar with arrays? At a declaration level, we'll go to the structure level here. So hang on. Can you say something? Yeah. I'm checking my audio here to see if anyone's streaming, if any of this was recorded. And my computer is being, hang on, my computer's being silly. Audio output capture. Device. Now say something, Inzia.
I like arrays.
There it goes. Okay. So basic things, structures with arrays. Okay, we go to coders, and then we'll add, we'll try to insert one, right? So next empty spot, right, equals 2. Equals 0. And then we can do something like this if we really want to be.
And then, yeah.
Well, you should probably give this a type. What do you think of int? All right. So the main thing with arrays is now we can do a return coder array. Okay. Then return this coders. Okay. Now our test should work, I think. So get all dot length.
Try count. I said that.
Oh, it's because I made up a library. I made up something, is equal to 2. I used the wrong assert language. So if we run this test, oh, data store 2. That was because that was the next thing I was going to do. All right, so array's great. Cool. We got an array working. Yay. We had 3. All right, I think we're going to get a nasty error because an array is just a set of boxes in a row. And I think when we add the third array, yeah, we have a test fail. And it's going to say something like index array out of index, which says in consecutive memory space, I just don't have any more space. So one of the ways I used to fix this was in the data store, I would just go ahead and create a new constructor or overload the constructor. And I'm going to go in the data store. And I would make this null, okay? And this is how Java actually works underneath the hood. Well, last time I checked in Java 8, we're in Java 1.8. I'm sure it hasn't changed too much. Is I would take a constructor here, and I would do something like public data store, okay? And I do size. Remember doing this? Have you done this before?
Yeah.
All right, coders equals new coder, and dynamically allocate it. So I get to declare the size of the array once. When I do it this way, I bet you my test works. Okay. Cool, right? You can say no. Well, our test didn't pass because we didn't change the size. There we go. So you had a question?
So now if we want to add another one, like 4 quarters, it should work because length is increasing based on that size.
Let's try it. So if I go and say coder 4, I want to add coder 4. If I don't go in, and I'll run this test. If I don't go in and actually re-declare the size of this, I'm going to get index out of range because it can't dynamically reallocate in space.
Right.
Array list, which is a common Java function, will dynamically reallocate it, but that's because it will destroy and recreate the array at twice the size. So it's not really efficient. I think Java 1.8 starts off with 10 empty slots on every array list. So if you add items of more than 10, then it has to stop, reallocate all the memory, and regrow the array.
Okay.
And so this is not good, is it?
Yeah.
All right. So the way we want to deal with this is, if we want to have the simplest thing that could possibly work, if we want to have the ability to add as many as we want, we need to switch to a dynamic data structure. And one of the simplest things that we can do is, if I can get my computer to work, is we can do a linked list. Are you familiar with the word linked list? Have you written one from scratch?
I am familiar what it does, but I haven't written anything that is linked list.
Okay.
Or I don't remember writing something like that.
So let's do this. Let's use a little dependency injection here, or we don't even have to do dependency injection. Let's call this data store array. Are you good with that?
Okay.
And let's experiment. Let's extract interface data store. Are you okay with that? And we'll have an add coder and get all coders. Are you okay with that?
Mm-hmm.
All right. And let's add it to get. Let's now that we've implemented this data store, let's go ahead and let's have a little fun here. Oh yeah, this is so much fun, isn't it? Yusuf's probably thinking this is so much fun. And so if we say this is a data store, I think this interface will keep. Okay. I don't know why it doesn't. Oh, that's because that's where the bug wrote. Okay, so if we use this data store again, I'm going to rerun this because I'm confident it'll work, but I just want to make sure really quick before we go any further. Yeah, cool. So let's just do this. Data store. We'll use some tricks of Java to make it on the same screen. Are you okay with this?
Mm-hmm.
So let's run our test again, and it'll basically say none of this is implemented. I don't know what to do. And let's go ahead and play around with adding dynamic stuff. Are you okay with that?
Mm-hmm.
Okay. So in a linked list, the idea here is it's like do you know what a pointer is?
Yes. So a pointer tells you the address of the next item it has. So it's like if we have an array, for suppose,
Mhm.
if the first item will have an address to the second
Yep.
item,
Yep.
and that's what it's pointing to.
Yep. So there's two ways to do this. We can add a pointer to the coder, or we can wrap the coder in a class. What I think we should do for fun is let's just build a simple container, right? I'll call it a coder container. I think that's funny. And we'll build a coder container. Let me do this. I don't think it matters if it's private or not at this scope. And in this coder container, we're going to put the coder, okay? Public coder, and that could be getting permissions wrong. So let me just do this really quick. So private coder. Goodness, it's been a long night. Private coder, okay. Private coder next. Okay. And then what can I make a? Yeah. Let's see. All right. And we're not going to look at the beauty of formatting this correctly because we don't really care right now. Getter setter. Okay. Next. Okay. So just made a container object there, and I'll implement it, and then we can talk about it. Okay. So the algorithm is really simple. If I add a coder in, right? So this add method, if I go to the line leader, remember in kindergarten when there was a line leader? Like there always has to be someone out in line. If you're the first person out the door, then you are the line leader, right? So let's just call this, instead of the head, that's a common computer science term. Let's call this the line leader because, kindergarten's best. So you get to the door. If there is no line leader, congratulations. I mean, Yusuf spent, what, 2 to 3 years in kindergarten? If you look at line leader, if you're not the line leader, then, I'm sorry, you get to the first door, then you're the line leader. And we'll change this to coder 1 for context. Decoder, okay? Else, what we want to do, actually we wanted to do this. We want to call this decoder container, and we'll walk through this in a second. And we'll say new coder container. Are you following me or am I being crazy?
Okay, you're setting that coder.
Yep.
Okay.
And then once that coder's, so actually we can just do it like this. The line leader, set coder, okay? If it's null, okay?
Okay.
If it's not null, then I need to go look for the end of the line, okay? And the easiest way to do that is to say, while line leader dot next coder get next does not equal null, then I'm going to go and I'm going to create a local pointer container. What do I call it? Coder container. pointer. So I'm gonna say coder pointer equals null. And then I'm going to say, oh, sorry. I will read you through this code here in a second because I made a mistake. It's Friday night and I'm doing data structures and algorithms. We need to rename this type really quick. And I'll walk you through this code. Thanks for bearing with me as we go through this. So coder container, okay. And, oh, that's because we put our variables at the bottom. Remember how great we were? And then this should do it. Okay. And this is just a container. All right. So we get the next coder and container. There's a bug in this one. So let me rederive this from heart, okay? So if I'm not the first line leader, Insia, if I get there and there's someone in line, then I say if container, if the line leader dot next get next container equals null, then, and I'm going to derive you through this, then the line leader dot set next coder should look something like coder container equals new coder container, and then I'm going to say coder container dot set coder to here. Okay, I'm going to create a new container, and then I'm going to say set the next line leader to this. All right, I'm going to pause there because I did not easily go through that. Does this make sense to you?
Okay, so in the first if condition, we are just checking that is there any user at all. If not, then we are just setting that as our first user.
Yep.
But on the second else condition, we are just we are checking that do we have the next? We have first user. Now do we have next one?
Yep.
And we have this equal to null, and then you're creating this coder container.
Yep. Because it contains a pointer. It contains the coder and the pointer to the next coder.
Right. And then you're setting that coder. Okay. Okay. Yeah.
Yep. And let's run it because I think it's going to test will anonymous class implementations cannot have. Where is it telling me this? Oh. Oops. So let's run this test really quick because I'm pretty sure the test will run. I don't think it'll pass.
So both coder and the next one, both of those are coders, right? We're just naming them as head and next.
Yep. The next, what's going to happen is when we run this test, is we can only store 2 coders. Yep. Test compiled. Test failed because we didn't implement the rest of the logic, but that's okay. But it didn't give us a runtime exception. So if we want to walk through it, let's walk through it. That'll be easier. Let's walk through it with the debugger. By the way, the best way to learn this stuff is to debug it. Step over, step over, step over, step over. Step over. Okay, let's go into it. Step into. All right. Okay. See. First one in, we don't have anything. So we're going to create a new container and we're going to add a coder to it. Okay. So the line leader is the first person in line. Okay, coder 1. Or yep. Then we're going to do coder 2. Step into. Now we have something there. Okay, we can go look at line leader if you'd like. You see, line leader's here. Of course, he has no values because we didn't type anything in, but that's okay. It's just memory. And now we're saying get the next one. All right, it's empty. And so we're going to go ahead and store the next coder in the space. Follow me?
Mhm.
Okay. Now, when we get to the third one, right, it's going to say, oh, well, the line leader next is not empty. Let's just exit because I have nothing to do. Okay. So what we need to do is write an algorithm, and this is a common interview question, is how do you find the end of the linked list? And so what you have to do is a little pointer work, okay? You just walk the line. Hey, are you there? Hey, are you there? Hey, are you there?
Mhm.
And so to do this, we save, okay? The easiest way to do this is, and I'm just going to use the word container, right? I'm going to say container pointer. Are you okay with that?
Mhm.
Equals line leader dot get next. Okay? We're going to substitute this out. Okay? And if it's null,
We don't need that get next on this line 73, right? Because we already are checking.
you are going to, yeah, what we want to do is this. So let's just talk about it out loud. It's easier. So the line leader not next, get next is, okay, that's the next person in line. Okay. It's called next. That's easy to remember. If next equals does not equal null, correct? Then what we want to do is take next and make next equal to next dot get next. Got it?
Yeah,
We're gonna
I
go down
think.
to the line. Okay? And right. So at the end of this, if net okay, so it's fun as you talk through this and talk out loud. We're getting next, right? And okay. Next equals null. And so what we want to do is do a while loop because this will advance this to the end. Okay. And we'll test this. So if next equals next, get next, at the end of this is, goodness, I'm having a brain fart. Let's do the easy part I know we need to do. Okay with it. So I'm just going to create a coder container because I'm having a memory hole tonight. Set coder. Okay, now we have the new one to save. Okay. And then while we're looking for the end, then we would say next. You know what? We're just going to debug this. We'll get there. I won't get through the coding interview tonight. All right, let's debug this really quick. And then you can tell me how crazy I'm in tonight because, yeah, that's where my brain is. Did I lose you on this, Cynthia?
Just trying to
It's
think.
okay to say yes, 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 you did. You did a very bad job. You lost me. I'm okay. Because next is null. All right.
Yeah, I mean, let's run that debugger and see.
Yep. That's what I was going to say. Okay. So F8, 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 F8. Okay. There it goes. First one works fine. We set the node. Yay! Second one comes through. We say, get the next one in line. Okay, we create our new thing. If next does not equal null, we keep moving to next. Okay? And this is our problem. You see this? This is null right now. Oops. Oops. And so because next equals null, the simplest thing that could possibly work is, what do you think, Ncia? Get next. Next equals null. I'm trying to short circuit this, which makes it hard for me to teach you how to do this. So this is make it easy.
So before while we can check that if next is equal to null, then next is
Let's do this. So what we want to do is we want to take, yeah, you're right. Keep going.
yeah, we have a check over here. If next is null,
Mhm.
then that's our pointer. Maybe we can rename this next to pointer because there are too many next.
Yep.
So yeah, if
The pointer.
yeah, pointer is null, then we have our what do we call
The pointer is null, then we want to assign it to the new container, correct?
yeah.
Okay. Which means, and the reason I made a mistake in Cia, because since we're using a container, the math is off by 1. So, and I'm thinking too much here in Java land. Do you mind if I just punch it in here and then we can walk through it?
Okay.
Okay. So, you know, the object-oriented people are going to be really mad. I don't care. Public static code container, create coder, coder. I'm just making my code a little more readable here so we can just abstract away everything. Okay.
So what is this create going to do?
I just wrote a method here to hide the creating of the new. What I'm trying to do is just make our code simpler to read. So just a second here. Get the coder, that's fine, but we don't want to be able to set the coder. Let me. It's giving me an error because the language level is too low to do what I wanted to do. Okay, what I want to do is just write a quick dirty method here, a helper function, to coder container, to create coder container. Okay with that, take the coder, put it in here. Okay, this is going to say coder container, new coder container, coder container dot set coder, right, return container. Got it? And then we can just do this. It's easier for me to read.
Mm-hmm.
I'm just going to abstract this all the way. That work? Yeah. So now get rid of all this complexity. What is it now?
Yeah, red line.
Yeah. There we go. So now we take the new.
Yeah.
That works. I'm thinking too far ahead of what we're trying to do. So now it's very simple. If the line leader equals, okay, we have that. Okay, so now if the line leader does not equal null, then I want to do is line leader dot get next equals null. Then I want to line leader dot set next, which is create coder container coder. Okay. And you're gonna laugh the way I'm gonna do this because this is the easiest way with the test to derive it. Are you laughing?
Yeah.
Okay. A little hard to read here, but let's just run it really quick. All right. So what we can do is, want to do it recursively, or do you want to do it with a loop?
Loop would be cleaner because
You don't like eating all the stack?
yeah, it's I do understand that we are going from next to next, but it's just too many words there. Loop would have like reduced some words.
Yep. So what we want to do is line leader dot get next equals null, then you set the line leader. If line leader dot
Next.
yep.
Ne-
So what I want to do, and this is the easiest way, and I was trying to do TDD, but sometimes it just doesn't make any sense because I know exactly what we need to do. All right, get last in line. Okay, and what this will do is while line leader, right? So what we'll do is we'll do coder container dot saved equals line leader, while line leader while saved does not equal null. Okay, saved equals saved dot get next. Return saved. Make sense? Saving a point in line, holding it, and now all we have to do is, I believe it's something like, very simple, like get last in line dot set next. Coder, create coder container coder. Now, this is hard to read right now. I do apologize, but yeah. Let's see what happens. Cannot invoke because is null. How does this save value? So we save the line leader here. Oh, because
Get next.
yeah. Let's try that. It's probably says the same thing. Because saved is null. Saved null. Let's debug it. Sound good?
Mhm.
It's easy to do this on a whiteboard.
It's easier than whiteboard.
Yeah. Because it doesn't have to compile. The logic's really simple, right? You have something that points to the next thing in line. So trying to remember this late at night how to do this is sometimes fun. Right. And this is where we want to, okay. So line leader saved. Oh, I know what the problem is. So when we get to saved, right, the next one is null. So we're setting this to null. Well, we don't want the empty space. We want the one right. We want the end, and we're pointing to the abyss. So the line leader dot next equals null. Then the last in line is here. I should have did this without a container. It's easier without a container. So if saved equals null, then is that the key thing? We'll walk through it here once I make it work. It's been one of those days. What did I do wrong, Insia? Tell me.
I think the condition was right that save.next is equal
There it
to
goes.
null. So then we want that save to set that next coder. So instead of save dot we are assigning save to save dot get next. That's null, right? On line 84.
Let's debug it really quick.
Okay.
Let's
So
jump.
first one save now, and then this is the second
Okay.
one.
Yeah, this is the second one. All right. So we got the saved. Okay. And now we're saying, let's look at the next one. If the next one is not null, let's advance. Correct?
And the next, so this get next, save dot get next is giving us second coder. Can you hover over that next get next? What is it showing us? What's the get next value? Do we have?
None.
Okay.
Because we're the first one in line. And so what we'll do is, right, since we're the first in line, then it's, oh, there's nothing beyond the first one. So the first one is also the last one. Okay. So let's step through it, because if we have this right, then this algorithm, okay, container saved equals line leader, right? So this first one, if I'm a betting person, okay, we have a value there, right? Then, okay, this now we just moved, we took a step forward, correct?
Mm-hmm.
This next one's null. Since it's null, then we're kind of doing like a peek, correct? Peeking ahead into the next line. And since this is not null, we'll go add another line. So then when we add the fourth coder, according to my calculations here, when we add the fourth coder, we'll go cycle once, cycle twice, cycle 3 times, and then exit. Does that make sense?
Yeah.
Okay. And then now we have a linked list. Okay. Test doesn't pass because this get all doesn't work. You want to implement the get all or not? Do you care?
Why is the get all not implemented?
Because we never wrote the code for it.
Then why are we checking its length? Oh.
Because that was our first thing we did with an array.
Oh, okay.
The whole point is here is to let's implement it really quick. The whole point of this is to have code we can play around with, where you can say, let's revert and do this with arrays and see what happens, versus what happens with other things. So the get all And I don't want to, we would implement an interface for Java, but it's too hard to think right now. I'm looking for the get all. Do you see it? Get all right here. This just returns an empty array. So what we want to do is we want to array list. Why not? Coder, right? Coders equals new array list of coders. I think that's the way Java likes it. And then what we want to do is we want to do something like this. While line leader dot get next. Same thing we want to do here. So save the pointer. Okay. Right. And then we say if saved does not equal null, then we want to coders the add saved dot get coder. Does that make sense?
Mhm.
So we're gonna go look in our container. If our container exists, then we're gonna go get the coder. Okay. And then we're gonna peek and do the same thing that we did here. And we'll save dot next coder instead of. I'm just gonna quit talking and type because I think it's easier to understand the code. What do you think? Does that make sense?
What is the add? Okay, and then you are just sending this coder. So in return, we will be just sending this coders, right?
Yep.
Okay.
Because we hid the container. We hid the container. What is it? It's gonna tell me something. I forget. It makes you do something silly here. You have to typecast it. Let's try this again. So I'll walk you through this code here in a second. Let me run this really quick. Oh no. It doesn't like that trick we just did. You're getting a runtime typecast exception.
Mhm. And this array list, the built-in one, is doing the same thing that we just wrote this test about. It's the same thing, but it's just they have this now in a built-in format.
Yep.
Okay.
Well, the array list is an array, and every time we add items to it, and I'll show you a cool test here. You wanna see Java arrays? It's a good thing to understand. Is let's do a test. Public void Java. We'll do array list. Okay. And so what we'll do is we'll create two array lists. Okay. We're gonna do one that's just set of numbers. 1 to 10 numbers. Call this one 10 numbers. We'll put 10. Array list. Okay. And then we'll do array list int all the numbers equals new array list int integer max value. Okay. All right, so let me walk you through this and why array lists, and depending on your language. Oh, can't be a primitive type, really? That's fine. Okay. And then, okay. So I'll walk you through this. All right. So in Java 1.8, which is what we're running, so the JVM is a really cool thing. The Java Virtual Machine, are you familiar with it? Ever heard of that term?
No.
Okay.
What was that?
JVM. The Java Virtual Machine is the Java is an interpreted language, and it runs. It's really smart. There's a lot of VMs out there, but a lot of languages work the same. One of the reasons Java is nice is because a lot of it's open source and old and understood. So, and it's more of a modern language. And let me just set it. So if we look at 10 numbers here, okay? When Java creates an array list, and this is coming from memory of a book I read 10 years ago, but it's still Java 1.8. So if I do for int I equals 0, I is less than 10, I plus plus, and I say 10 numbers, add I, and run it, okay? We will go ahead and we will create, and this is probably, I ran out of memory. Let's comment out this one right here. This is some stuff to show. This is what you wanted to learn. So this is, a good demonstration. Okay. So I created an array list. Okay. When I jump in here and I start debugging, I'll show you this. And I debug my array list. It says the size is 0. But if you look at memory space, and you can't do it with this debugger, I think it actually has 10 slots for integers and memory allocated. So it went off and carved out a slot of 10. So if you only have 2, you're still using the memory space of 10. If you only have 3, you're using the memory space of 10. When you get to 11, it'll stop execution and dynamically reallocate twice as much of your storage. So it'll create 20. So if you're adding the 11th item, then wow, right? I now have an empty 9 slots. The thing is, I just spent the extra time creating the array list twice. Okay. So now we'll show you what that looks like in comparison. Let me just steal this test. And there's a couple things. This is why, it's fun to do it this way. We'll call this one array list all. Okay. And same thing. We'll do let's do 9999. Okay. And let's run all of our tests here. And stop me if you're not following here.
So what's the reason using 999?
Just because it's a big number. Okay. Every time, and if you pull up something called Visual VM, I don't know if I have it. I don't have Visual VM. If you look at Visual VM, you can look at how the Java Virtual Machine is working, and you can see it stop what it's doing and start reallocating reallocating memory space. Okay. And so let me circle back here. When we have an array list of 10, we're good. Okay. When we have an array list of 999, awesome, right? It works. It's going to be much slower. Look at this. Look at the speed. Let's run all of our tests. Unless, this isn't the greatest performance monitor, but it's a good indicator. Yeah. So this took 3 milliseconds. This took 492 milliseconds. Now watch as I take this, call this 1, 1, and we tell the JVM how many slots to create. Watch how much faster it runs. I don't know why it keeps that.
I think because something's failing.
Oh, restart debugging session. Oh, we're in the middle of a debugging session. I don't care. So let's rerun all this. Okay. So if you look at array list all 1, right? 4 milliseconds. If you look at array list
It's right there underneath.
all
2 milliseconds.
Well, that doesn't tell me the story I wanted to tell.
It's the opposite of what you were telling.
Yeah, it's that took longer. This should, I don't know, maybe it's, this is, like I said, this is not a good profiler, but it's the same thing. It is going out and having to create more space for this one, whereas in this version, it doesn't work. Now, let's take this, right? Let's do array list, and this is why arrays are dangerous, right? Array lists are bad. Break it. Okay. Let's just say integer dot max value. Okay. Let's not even tell it how much it's getting. Let's run all these tests. What do you think it's going to say?
I think it will just keep running until it gets to maximum value, whatever that is.
What do you think it's going to stop? What's going to stop it? Getting to the end of the for loop, or?
When does it stop?
Yep.
Oh, don't know.
I ran out of memory. Now imagine trying to debug your code when that happens.
So this max value can be in like thousands.
Yeah, it's the integer max value. It's 2 to the 32nd minus 1. 2 to the 31st minus 1. It's the biggest number in Java. An integer, you think you should be able to store it in an array. Did I lose you on that one? It's 214-478-3647.
Yeah. Yeah.
And what's happening is not only is it running slow, because every time array list grows, it has to reallocate and redynamic things. It runs out of space at any time. And so if you look at how much memory I have, and I don't know if I'm running out of memory. I don't think I'm running out of memory. Let's run the test and find out. I don't think I'm running out of memory. I think the JVM's not tuned. But let's watch the memory go up. Right? Oh, maybe I am running out of memory. I have 32 gigs of RAM. You would think this should be able to run, right? I ran out of memory for the JVM.
So what do we use to save our memory instead of using this array list?
Aha. Remember that thing called a linked list?
But that's also like it's also it has a pointer. That's the only difference, right?
Yep.
It can, but it works similar to array. It just keeps growing.
Array is a continuous line of memory allocated. Arrays are really fast. Okay? Because arrays work, because the way an array works is, let me see if I can do ASCII, or I'm not sure if I can do this anymore. Array that works is, it says I have a slot. Okay, here's my 0 slot. It's size 512. Okay, here's my 1 slot. It's size 512. Okay, arrays are great because mathematically I can go find the third slot by saying look at the 3 times 512. Where arrays fall on their face is your memory has to be that free in most languages continuously. So just because you have empty memory doesn't mean you can actually use it. It has to be in a line. Okay? Does that make sense?
Yeah.
And when I look at array list, okay, all array list is doing is it's just recreating arrays. It makes you think it's an array list, but it's just recreating arrays underneath the hood. When I look at a linked list, right, and we'll use Java's linked list because we wrote one. It's kind of nasty. I don't know why we'd ever want to write one. You know, we need to know how to write one on a whiteboard for an interview. But when we're asked how a link array list works, it'd be something like, when we're asked how a linked list works very similarly. The interface looks very much the same, doesn't it? Like
Yeah.
that. But this time, I don't think I'll run out of memory. Because what it's doing is it's just adding a number in line.
But we are still storing that value in the memory, right?
It's storing it in memory, but it's not saying I need to allocate this much space in a continuous line. So it can go poke around. So think about your kitchen. You have many cupboards you can store different things in. Like your cups can be stored in all the cupboards. Although it might not make sense, you can find a spot to put almost every cup in your house in your kitchen. The way arrays work is all the cups have to go in the cup cupboard in a row. And it doesn't work that well when you're trying to create big data structures. And the other thing we haven't talked about is putting this on disk. Because at a certain point, you have to do this type of work and serialize it to a file. Because you just can't possibly store everything in memory. Well, you can now because we have like terabytes of memory, but still there's a practice with data structures and algorithms where you serialize this to a file. See, it's still running, but we're not going to run out of memory, I don't think. Maybe I spoke too soon. No, we're not really using much memory here. Takes a while though, doesn't it?
Yeah, thing is that it's not breaking. It just keeps going.
Yeah, it'll end because eventually we'll get to the max value. But it's slower because it has to go find the next slot. And now you can make it faster by keeping, depending on the implementation. I'm sure linked list from Java is very good. You can keep track of where the last container is. But now it's also it's creating a container itself for each number on the fly.
So in comparison, linked lists consumes more time than arrays.
They can.
Okay.
But linked lists are how you deal with large data sets.
Okay.
And they're dynamically allocated in memory. If you have constrained memory, linked lists are nice because you can. Oh, what happened? Did I run out of memory? I ran out of memory again. So that's a bad example, but let's do. This is something where you just have to play with it. The science is the same. I'm running out of Java heap space. But we can sit there and let it run, but let's talk about it. So the linked list it's nice, and all you need is a pointer pointing to the next item. Okay? I'm going to show you a couple other things in linked list. And I'm just going to do it with the coder object, and we're just going to talk variables, and we're not going to write test. Is that okay?
Okay.
So there are different types of linked list. Okay? There's singly linked list and doubly linked list. There's also other types, but those are the two common. So if we do something like previous coder, Now I can have a doubly linked list. So imagine you're in the line, in the middle of line in kindergarten, and Yusuf's the line leader, and I'm at the end. One of the values of having a doubly linked list is I can go backwards or forward. I can rewind and fast forward. If I have a singly linked list, I always have to start, and I can't really go backwards unless I start peeking A and doing some fancy memory looks. But the doubly linked list will just have a previous and next annotation on it. We can write that out if you'd like, but it's really simple.
So this would be like when we are setting that next coder.
hmm
We are also checking that if it is first one, it won't have previous. If it is next, like if it is second user,
Mhm.
then we are saving our first, we are saving head
hmm
to this previous coder, and then we are the same goes on, that this next coder would be the second coder that we are
Yep.
adding.
Yep.
Okay.
So let's do something like that. You want to do that something like that really quick? Do you want to show? Do you want to talk about trees, or is it too late?
It is too late.
Okay, we'll stop.